Hello, hello, hello. Welcome to my latest live stream. Please comment below. Let me know where you're watching this from and that you can hear me. Hopefully there's some voice coming out at your end. So today we're going to continue working through the Boeing Starliner Propulsion Anomalies investigation report. And we're going to explore it through the lens of STAMP, STPA and CAST. So of course, if you've got any questions, comments, compliments, commiserations, please type them in the chat. And let's try and make this as interactive as possible. So let's just check that it's coming through. It seems to be hopefully coming through. There we go. Right. So where we got up to yesterday is we started going through, help if I shared the screen, wouldn't it? Pardon me, there we go. So we started going through section 4.8, common observations and organisational factors. We finished section 4.8.1, testing, and now we're going to do the next one, 4.8.2, which is best practices. So I'm just going to check the live stream's working. Just bear with me. Yes, it seems to be working. Some voices coming through. There we go. Look at that. Fantastic. Right. So best practices then. So organizational factor number 10. Actually, let me just put some headings. Sorry, not headings, some bars in there so it's easy to see what's what. So organizational factor 10, organizational factor 11, observation 1, observation 1, 2, 3. Maybe we'll get to certification today. We should do. I mean, there's so much to go through. It's a huge report, 311 pages, and we're at almost page 100, I think. So we've done well to get this far. I don't know if there's any other crazy people that go through investigation reports, literally line by line, like I've done with this one. But I hope it's helpful. I hope this work, whilst it's good for me, because obviously I need to read the reports, do my case study, fantastic. But do these live streams benefit you? Are you getting a lot out of them? You know, are they a bit tedious? You know, just comment below and let me know your thoughts. Because, of course, if it's not really very useful for you, me talking through an investigation report, then I won't do any more live streams on it. I'll just give you the results. But if you like to hear the thought process behind it, then please let me know so I can keep going. When the going gets tough. There we go. So best practices then. Let's talk about this. So organizational factor number 10, anomaly resolution process. So let's just zoom out and grab a jigsaw piece. So when we're talking about a process, any kind of process. So anomaly resolution process. So the process itself has to be enacted by somebody or something. So it doesn't exist in isolation, unless you're referring to a document that contains the detail of that process. Now, of course, a process can't influence a controller unless that controller has been essentially programmed with the content of that process. And when we're talking about things through the lens of a control loop controller, we're talking about the control algorithm, the decision making of the controller, and we're talking about the process model or beliefs. So for any kind of process, whether it's an anomaly resolution process or whatever, that the content of that document or description, instruction, has to find its way into this controller. So the question there's two questions. The first is, who is the controller that is responsible for creating, defining, and making sure this process is working and then updating it? So that's the first question. So if this was the process controller and this was the process itself, control process, funnily enough, you know, anomaly resolution process, then who is this stakeholder? Is it a person? You know, in the modern age, is it an AI that's squirting out a process and people are just using it? What is it? Who is that responsible party? And then, of course, if this control process is the people or organization that needs to follow this process, then who or what is responsible for making sure that process is put into that context and make sure that the controllers in this control process that need to follow this anomaly resolution process, how do we make sure that their control algorithm and process model have been updated and are correct and are maintained that way, that are current and correct throughout the life cycle? So again, I'm just trying to drill into your brain this control loop. So an insufficient anomaly resolution process. Hang on a second. What is going on with this? There we go. Insufficient anomaly resolution process directly contributed to the failures seen during the crewed flight test, specifically not pursuing validating the proximate direct cause of the anomaly. So is that the processor's fault, or is it the organization, the control structure that is charged with actually fulfilling that process? Because that's two different questions. If the process is nonsense, then we can't be surprised if the execution of that process is going to have issues. So is it the process itself that's incorrect? Is it the creation of that process that's incorrect? Or is it the way that process is implemented in an organization? So there's a number of different questions there, and we have to be specific which one of those questions are we actually referring to? Or is it all of them? Because it could very well be all of them. See organizational factor 1, insufficient anomaly resolution process for supporting data. And there's something I've forgotten to open up. Just bear with me a second. Because I need the investigation report available, don't I, in case I need to refer to it. So let me just get that open. There we go. Right. So what page is factor 10? Factor 1. Factor 1. Contributing factor 1, organizational factor. Organizational, and it's with a Z. Organizational factor 1. Not 15. Oh, apparently there's only 13. Oh, maybe it's 0, 1. No, it's not. Okay. Okay, factor. Oh, where is it? Why isn't it? Doesn't the word search function work anymore? Come on, what's wrong with you? Okay, well, that's a bit annoying. So organizational factor 1. Where is organizational factor 1 then? Observation 1, recommendation 1, organizational factor 7. Recommendation. Where's the organizational factor number 4? So it's before there. It's not under there. Organizational factor 1. Where is it? Is it really that far back? Evidently so. If only the word search function worked. I'm trying to find the organizational factor number 1. For some reason, the word search does not work. Ah, there it is. There it is. Found it. Look at that. Organizational factor 1, insufficient anomaly resolution process. Right, so let's just take that and then we can move it to wherever it is over here. Where is it? Over here somewhere. There we go, that one there. Right, so insufficient anomaly resolution process directly contributed to the failures seen during CFT. Specifically not pursuing validating the approximate direct cause of the anomaly. This is further evidenced by the fault tree complexity. So fault tree analysis, comparisons of OFT1, OFT2 and CFT crewed flight test, orbital flight test, fault trees. So there's 3 sets of fault trees mentioned there. The OFT1 fault tree had only 3 sections and only 21 failure modes, submodes. The mission elapsed time anomaly convinced team leadership that the root cause of the thruster failures was due to excessive duty cycle commands and thus influencing decisions to not pursue the additional ground testing or create a robust fault tree. So if we were talking about the mental model and the beliefs of the team leadership, whoever they are, because it's not really clear what team, what leadership. Are we talking about safety engineering leadership or flight test operations leadership, or who are we talking about when we say leadership? And again, this is one of the benefits of using CAST as part of an investigation, because when you build the control structure model, it forces you to make explicit who you're talking about. So just saying team leadership, well, who are we talking about? Which bit of this control structure is team leadership? If it is a load of different, leadership entities that are doing various things, you can refer to them as, a generic term, but you should still at least attempt to try and be more prescriptive. But the mission lap time anomaly convinced team leadership that the root cause of the thruster failures was due to excessive duty cycle commands. So that's control actions, thus influencing decisions to not pursue additional ground testing or create a robust fault tree. Well, I'm not quite sure I understand or agree with how that has been concluded, because surely if they were having issues with the spacecraft, they should have done ground testing and the fault trees anyway. The thing should never have taken off without a robust fault tree. And you could say, well, hang on a minute, Simon, you've just been banging on for days and days and hours about how fault trees are a load of nonsense. And my view is that they're not complete nonsense. They can be helpful for certain specific tasks. But if we rely solely on the fault trees and how good they are, we're, of course, going to miss stuff. And we clearly have missed stuff in this situation. So fault tree on its own is not enough. And it's certainly not enough when they're not done to a good standard. But again, the reason they're not done to a good standard is something the investigation should go and look at. Why would it make sense for them not to be a good standard, to not cover all of those things? What is the control structure around the creation of those fault trees and the review of those fault trees and the acceptance of those fault trees and, making sure that they're changed and updated or reviewed after an incident or near miss? Anyway, let's keep going. I'm moaned enough about that. So the RCS thruster, RCS thruster B2R3 did not respond. So this top event in this fault tree is very specific about one particular thruster. So the thruster did not respond. Electrical control, mechanical structure, or fluid system. So very simplistically. So electrical control is where you'd anticipate the control actions to be considered. Mechanical structure and fluid system, they would be considered as inputs and outputs or contributors to the control path or feedback path, or even the controller ability to control itself. So OFT1 failed RCS thruster. OFT2 fault tree had 5 sections and 83 failure modes. And submodes, blankety blank masked any opportunities for additional learning, immediately became the focus of the failure investigation. Better but not comprehensive fault tree. So again, I can't really read what those say. That seems to read other, don't know, command, I think that says. Mechanical, I think. This bit, I don't know. I can't really read that. The CFT RCCA thruster fail off fault tree. So again, I'm highlighting this with purple because in my sort of convention of highlighting things with lots of colours, purple represents a document of some description. So this fault tree analysis will be in some kind of report, I'd like to think, that's been reviewed and signed off and is config controlled. And maybe it's got a fault tree file, a software file that goes with it. Maybe some spreadsheets. Okay, so the fault tree had 10 sections, 351 failure modes. My gosh, that sounds like a painful fault tree to create and review. The CFT RCCA fault tree is thorough and robust. You can have the most thorough and robust fault tree in the world. It's still not going to capture stuff that STPA captures. That's a fact. However, low data rate sampling and lack of recovered hardware hinder post-flight evaluation of system performance. Okay, so we've got whatever that says. Materials, I think, mechanical, maybe materials. Dunno. Manufacturing, dunno. High explosive areas. Oh, high emphasis areas. Sorry, not explosive. High emphasis areas. Testing, something else. Dunno. Okay. Great. So this section is all about the anomaly resolution process, but all they've done is talked about the quality of the fault trees. So what is it about the process? What is the process? Is there a reference number for it? Is it that they were using an old process, or that it was an obsolete process they shouldn't have been using? What is it about the process? Why is it not discussed in this section? I want to know, or the audience wants to know. Come on, what is this discussed elsewhere? I don't know. But this bit is not adequate. There's not enough there, not enough going on. And I'm hoping, just thinking about things through the lens of the feedback loop, you're starting to think, well, yeah, Simon, I kind of see what you're talking about. These things need to be addressed. In fact, shall I just make it really explicit while I'm at it? Let me just... No, I didn't want to do that. All I wanted was... Oh dear, what have you done, Simon? You made a mess. All I wanted was the grey text. Oh, I'll just use that. There we go, that's quicker. Right, sorry, let me just do this again. So if you imagine that anomaly resolution process. Right, so imagine that this, for the purposes of the investigation, this is the anomaly resolution process at the top, and it is implied that a control action from that process goes to the control process, which is the project, the program in this context. Project or program. And I've spelled program wrong. There we go. Got an extra R in there. There we go. Right. So if you think about it simplistic like that, we've got this piece of paper with some stuff inside it. And that stuff is intended to influence the program or the project and the people that do the work. So we can start thinking about it like this. Well, how does that anomaly resolution process find its way to the people in the program? What decisions does it contain? Does it contain criteria? Does it contain requirements for information? Does it have references that inform its process? And then we can think about, well, oh dear, what have I just done? And then we can think about it from the perspective of, well, what if this is the process? What if this is the process here at the bottom? Who is the organizational sponsor responsible? Why is that wrong? Is it OR? There we go. Organizational sponsor, responsible stakeholder. So they're responsible for the process. So what is it they do about making sure this process is up to scratch and actually works? What feedback do they get about the process or from elsewhere to make sure that this process is working? And then the next part is, I think I've talked about that to death. So I suppose you could say that this controller There we go, is like that. So the organizational sponsor, responsible stakeholder for the process itself, and then the process and how it affects the program. And then ultimately you have the actual content, control actions originating from fulfillment of the process. So whoever does the actual investigation and the work. So you can see there's a bit of a mini control structure there for the context of the process. I hope that makes sense. So let's just move that up a little bit. Group. No. Yeah. There we go. Bring that to the front. There we are. Right. Let's leave that there like that, shall we? Let's steal that one. Okay. So let's go on to organizational factor number 11. So repeated acceptance of unexplained anomalies. That's what it is, isn't it? Is that what it is? UA. Unexplained anomaly. Yes, that's what that means. Pardon me. So unexplained anomaly. So that's what. So let's have a think about this then. So if your leadership in the program is, so this is the program itself and this is the leadership of the program. If they're getting feedback which are essentially unexplained anomalies, that should be a bit of a warning flag as to something's not right here. Either we're not doing a process properly or detailed enough, or there's something genuinely going weird. So what beliefs did that leadership have? What decisions were they making? And what control actions did they provide based on these repeated acceptance of unexplained anomalies? Why would it make sense to keep accepting those things? You know, who or what is involved in this as an independent assurance loop that should be saying, well, hang on a minute, leadership, you're accepting these unexplained anomalies. Why aren't you doing anything about it? Where's that independent assurance loop? How are they implicated in this? So the anomaly resolution process directly contributed to the failures. I'm not sure I agree saying that it directly contributed. Maybe there's a rhetorical sort of discussion there about, well, when we say directly contributed, what do we actually mean? Because like I said before, really, when you're talking about direct contributions, you're really talking about the physical process where harm occurs, and then those controllers that are directly in physical contact with that process. Whereas an actual administrative process is really quite far removed from that front line. So how can you really say that it's directly contributing? Maybe that's rhetorical, but anyway, let's keep talking. Let's keep moving. So the STAR report cited how Starliner, Boeing and NASA has repeatedly not sought root cause to many IFAs. I think that's in-flight anomaly, isn't it? IFA. In-flight anomaly, everybody. Look at that. See, I'm getting really good at remembering. I'll forget in a minute. There we go. In-flight anomaly. So Boeing Starliner has repeatedly not sought root cause to many in-flight anomalies, instead dispositioning many as unexplained anomalies, such as the thruster failures on previous flights. Right, so let's just explore that for a minute. So if this controller is Starliner, Boeing, NASA as an organization, and they repeatedly not sought root cause to many IFAs, and they've instead dispositioned many unexplained anomalies, dispositioned many as UAs, down here, control acts, why would it make sense for them to do that? Is it because there's loads and loads of them and they're overwhelmed and there's not enough people or resources to deal with it? Or maybe there's not enough time because the timescales are ridiculous. Or is it that their investigation method is not particularly helpful for these kinds of failure, non-failure, interaction type accidents? I'm kind of thinking it's a mixture of both of those. And the recommendation, of course, is going to be, the people that are doing these investigations, these root cause analyses, they need somebody or some people equipped to use CAST to be able to help them do that quickly and get better, more specific results. But of course, that's only going to work if the leadership are willing to take on board that there are issues that need to be resolved. Because you can have the best safety analysis method, the best investigation method in the world, but if leadership are not going to pay attention or give you the resources needed to resolve the issues, then you're just shouting into the wind, and at some point you're going to get demoralized and leave the organization. I mean, it'd be interested to know what the staff turnover is, safety engineer and investigator turnover is in this situation. What the sickness rate is and stress and all that kind of business. Okay, key example being the acceptance of OFT 276 UA RCS thruster injector temperatures during soakback appear to have exceeded temperatures observed during qualification. This anomaly is directly pertinent to the most probable cause of this failure. As outlined in Loss of 6 Degrees of Freedom Organizational Factor 10 anomaly resolution process, there was sufficient information to identify the thruster failure mechanisms on OFT2. So there was sufficient information to identify the thruster failure mechanisms on OFT2. Okay, so there's a question here over the quality of the investigation and the method that they've used to do the investigation. Acceptance of OFT242 AR114 unexplained anomaly. The in-flight OFT helium leaks at JPCB on February 2nd, 2023. Pardon me. As outlined in the helium leak organizational factor 10 anomaly resolution process. Lack of recreation to these failures inherently generate risk as developing changes based on unidentified causes could result in the repeat of the anomaly on future flights. Yeah, I mean, there's also developing changes, making any kind of change anyway, especially when you don't understand what you're trying to fix. That could generate and introduce new problems, new second-order effects that might even be worse than what you were trying to avoid in the first place. So you've got to be really, really careful, really balanced. Okay, current testing is not seeking to demonstrate the exact conditions of the crewed flight test flight of the RCS thruster fail-offs. The goal of testing is seeking to demonstrate that excessive heating that occurred on CFT will not occur with the planned modifications to the Starliner service module. This inherently results in accepting risk as there may be unidentified elements that may not be understood by only seeking to prove not to recreate the event that may or may not have occurred. Yeah, I mean, that's a good point, that is a good point. There is a balance that must be pursued as to the time, money, schedule is spent to ensure safety. However, by not seeking direct cause of the failure results in a prove it's not safe mentality. Oh my gosh. This is one of the banes of my existence. The number of arguments I've had with project managers and senior leaders is about stuff like this and risk decisions is, oh, well, what's the probability of this happening? It's so unlikely that we don't need to worry about it. You need to prove to us that it's not safe before we'll take whatever you say is serious. And that kind of behaviour is a sign of toxic safety culture. You know, if you can't have open and honest conversations with people about it that are respectful and appropriate, then you really are going to struggle. And of course, it may be that the leadership, they're under a lot of stress and pressure themselves, and they defaulted to this kind of default simplistic way of thinking and simplistic safety culture. That's what happens when people are under a lot of stress. You go back to your base programming, basically. So I can understand that, but this is something we have to be constantly vigilant for and address. And impacts the safety culture. Yeah, there we go. Fantastic. This directly relates and is impacted by organizational factor 6, insufficient recognition of risk. Okay, so let's just... Oops-a-daisy. What have we just done? Gosh, it's hot in here today. Right, organizational factor 6, insufficient recognition of risk. So that one, isn't it? Yeah. So organizational factor 6, I think, is in the next section below, isn't it? Yeah, I think it is. Let's just zoom to that bit, shall we? There we go. Right, let's have a look. Organizational factor number 6, where are you hiding? Come on, where are you? You're in there somewhere, I know you are. Excuse me. Oh, there's number 8. There's number... So number 6 should be quite close. Number 2, 3. Oh, there's number 7. So where's number 6? Organizational factor number 6. Ah, come on, where is it? There it is. There it is. I've found it. Found it. There we go. Organizational factor number 6. Insufficient recognition of the risk. So that is the beliefs, the process model of whoever they're talking about, leadership or whatnot. Okay, so let's go back down here. This was also identified by the STAR team. There is already a recommendation from the STAR. Use as dispositions should only be considered after exhausting options for hardware changes. Again, it could be software contributors as well. Increase the rigor in evaluating UAs by investing in more hardware testing, recreation of failure modes to validate fault tree closure rationale. So yeah, I agree to some extent, but my major point is you should use STPA and CAST, or use CAST and inform STPA. You know, I mean, you could do a review of the fault tree using STPA and immediately find gaps in it. That might go some way to help understand the anomalies a bit better. The closure plan for the CCP program for the associated Action 22. So Action 22 CCP program which is evaluate NASA participation in Boeing PMRB to ensure proper elevation of risk acceptance. So what is PMRB? Boeing Prime Material Review Board. That's what that means. Okay, fantastic. To ensure elevation of risk acceptance. Observation 1. Mission appropriate usage definitions. Boeing did not define the thruster usage requirements adequately to subcontractors. Okay, so if we imagine our little control loop, if this is Boeing and this is their subcontractors, what is it about this control action which is to it's about thruster usage requirements. So they've didn't define it, or they weren't adequately defined. So that's well, why would it make sense to do that? What's going on? As a result, the thruster profiles operations given to the vendor subcontractor did not cover the worst case operation. Oh, dearie me. When combined with the insufficient definition of the thermal environment, the firing sequences for CFT, which were not worst case, resulted in the thrusters exceeding their qualified temperatures. Right, so, I mean, that's a huge thing. Why would it make sense for them not to do that? And how can we prevent that in the future? There needs to be somebody across this interface that's basically refereeing and making sure they provide adequate requirements. And if they're not, then making sure that that is escalated and addressed. Okay, this observation stems from the RCCA team investigation. 2.4.2 thruster usage ConOps definition. Ooh, ConOps, everybody. Reviewing a ConOps with stamp STPA is a fantastic way to find holes in the design or on the concept itself. This was previously tracked as a top... oh dear. This was previously tracked as a top risk prior to OFT1 for NASA, as the risk is insufficient thermal environment correlation for the worst case predictions was highlighted as the top risk during Boeing RCS OMAC engine qual issues for CFT in 2019. So they knew about it. This wasn't a failure. They knew about it. So how did this get through? And this is the thing that's a little bit frustrating about this report and others similar to it, is they say these things like that, and then they just leave you hanging. You know, they say this is the what, but then they don't say, well, so what and why? Because we need to, you know, this is all great, but so what? And then what have you done about it? Why is it important? What are the actions? What are the recommendations? There seems to be a lot of loose ends, open ends in this. And, you know, I'm not criticising the investigator because I understand how difficult it is to do something like this and write it up in a technical report. But there should, you know, if you think about the control loop for the output, which is this report, somebody should be reviewing this to make sure the report covers all of those things and make sure there's no loose ends or unexplained, you know, dead ends in the report. Because it just it's wasted effort then if you don't then follow up on it. Then it undermines the credibility of the report and the investigators. Oh dear, right, it's very hot today. I'm very, very hot. Right, here we go. So observation 1, certification. Commercial services model risk acceptance, reduced technical oversight and shared accountability framework by design shifts responsibility to the provider and reduces NASA's direct insight and control. Straight away then, it sounds like the control structure that existed prior to commercial crew program was different to how it is for commercial. And those changes in responsibilities and structure and proximity have probably most definitely contributed to this accident, this issue. While this offers the potential to deliver speed, innovation and cost savings, really? Is that right? I don't think I've ever seen examples where that's happened, but anyway, especially on complex systems like this. It also introduces increased uncertainty in the final product, particularly when coupled with shortcomings identified in testing and a shortened finite test flight campaign. While no amount of NASA oversight can guarantee zero risk. No. Please, if you're going to write a safety investigation report or a safety report and you talk about, you even mention guaranteeing zero risk, you undermine all credibility, because we all know that we can't achieve zero risk. We know that that is a panacea. So why include mention of it in the report? Because it's like, it'd be like mentioning pink unicorns or something. It's irrelevant. Anyway, I'll get off my high horse. Or schedule compliance. The agency must be deliberate in acknowledging and accepting an elevated risk that missions may fall short of key objectives or even fail as a consequence. Well, yeah, I agree with that. But at the end of the day, if you think about things through the lens of STAMP, STPA and CAST, the control structure should be adequate for the hazards and risks that are mentioned. And if you're just going to accept the potential that that structure is not going to be adequate because it's not been engineered or implemented correctly, then you're just going to end up with an unknown level of risk and potentially more risks, more accidents than you expect, and resultant more cost. That's what we're seeing here. It's not delivering speed. It appears to deliver speed and it appears to give innovation and cost savings, but it's just accumulating technical and safety debt. And at some point, that debt has got to be paid, whether it's in lives or cash. That's the end of it. So yeah, interesting observation. But this is an absolute prime candidate for digging in to, well, what is the control structure? What are the roles and responsibilities? How are they allocated across the control structure? In fact, I'm going to get my pink pen out and draw a big line around it, because I think this could be a fantastic topic that should be further investigated. And it's just one paragraph. Anyway, verification. Verification discipline. Boeing submitted rationale for requirements verification that did not fully meet the intended rigor or completeness expected for the verification method or associated waivers. Okay, so again, why did Boeing do that? Why did it make sense for them to do that? Is it because they didn't have enough time or money and they just needed to throw something out the door and that was the way to do it? I'm not pointing fingers or criticizing people, because when you're in a complex program, those kind of behaviors end up becoming the norm in some cases. They are very dangerous and risky behaviors, but that's, let's not be shy about it. That kind of stuff does happen. So how do we make sure that it doesn't happen? How do we engineer the control structure to avoid that kind of nonsense? NASA in turn accepted this rationale without requiring sufficient supporting evidence or justification. Again, why would it make sense to do that? If we're talking about responsibility shifts, for Boeing and, NASA, then we shouldn't be surprised when that happens. This mutual departure from expected verification standards contributed to reduced assurance in system maturity. Yeah, fantastic. Okay, so what are we going to do about that, everybody? Observation 3, shared accountability. The shared accountability was not understood, fully embraced by the industry partner NASA, nor were the expectations from NASA adequately captured. So, is it? What does shared accountability actually mean? Because if one person is not accountable, or one organisation is not accountable, and it's many, then no one is accountable. A single focal point needs to be held accountable And then the way that they implement things, responsibilities and accountabilities and actual capabilities and resource to do these things, that has to be considered. So I think, having shared accountability is not a good idea in the starting point, because you're diluting responsibilities. No one is in control. Somebody has to be in the driving seat. It can't be everybody or nobody. Anyway, and the expectations from NASA were adequately captured. So if this is NASA, hang on, if this is NASA, this controller, and this is the program, and their expectations were not adequately captured or communicated, then whose responsibility is that? NASA, somebody somewhere in NASA, some team is responsible for doing that. So did they do that? Did they not do that? Did they do it and then people just didn't listen or do? Were the people that's supposed to do that were not being held accountable? Could not be held accountable, maybe? Again, this is a hot topic for a structure part of the control structure consideration. As noted in May 18, 2025, CCP certification and COFR charts provided to NASA management councils. The Crew Commercial Program utilized a new to NASA shared accountability for its certification approach. This is the control structure. This is an issue with the structure and the way responsibilities are made explicit and communicated, and then people held accountable for it. This basic premise of this approach relies on two premises. The industry partner to be responsible for the design, development, test, and evaluation, culminating in their certification assertion of its CTS to transport crew. Right, what's CTS? CTS. CTS, there we go, Crew Transportation System. That's what that means, everybody. So the industry partners to be responsible for the design, development, test, and evaluation, culminating in the certification assertion of its crew transportation system to transport crew to and from the ISS. NASA CCP is accountable for ensuring compliance to CCP's human spaceflight requirements through evaluation and approval of the contractor's compliance evidence and execution of NASA's insight into the contractor's solution in accordance with a risk-based insight approach implemented under shared assurance. So this risk-based insight, I'm going to be controversial here, but who decides what risks, what criteria, and what topics to look at? Is it the safety organisation? Because this is not looking at everything. This is looking at certain things. So by definition, it's not looking at everything. So who or what is the controller that decides that? What criteria decision making are they making? And what resources do they have available to do that? Because if they're not resourced to do it, or they're resourced to only deal with a certain number, then of course things are going to get missed and dropped. And if you're relying completely on the industry partner to be open and responsible and everything else, then we don't, being open and honest, we don't live in a world like that. You have to trust but verify. And if you're not resourced or capable of being able to verify, then this is a huge risk. This is a very, very big risk that is not being managed properly. And again, this bit here is responsible for design. So they're responsible for design activity, development activity, test activity, and evaluation. But where does it say they're responsible for the safety of the crew, the safety of the mission? How is that? Where is that dealt with? So again, this is a prime topic of inadequate roles and responsibilities allocated inadequately to a control structure that's not fit for purpose for this type of high stakes situation. So again, this is a big topic that needs to be investigated further, because unless this gets fixed, they're just going to have repeats of this nonsense over and over again until people get killed and they run out of money. That's how it works. You know, we can do fault trees to death, but if this nonsense is not sorted out, well, it's just a matter of time before something happens. And again, as a taxpayer, not in the US, but if I was a US taxpayer and they were wasting billions on this kind of stuff without it being done properly, then I wouldn't be a very happy taxpayer. Anyway, let's keep going. So government industry accountability. Here we go. So this, I'll just zoom out actually. Let me just go to where are we? Yeah, there. Yeah, that one. Yeah, let's steal that one. Let's take this one down here. There we go. Let's take this and scribble on it. Where were we? There we are. Oh, I need to put a blue line around it, otherwise I'll not. There we go, blue line. There we go, that's it. Right. So think of it, actually, I can chop this down, can't I? Pardon me. There we go, right. So it's like that one, but it's got roles and responsibilities written on it. Slightly different size, but anyway, right. So let's just think about this for a minute. So each controller in the control structure has either logically or implicitly or explicitly some roles and responsibilities. And by definition, they should have the capability, the resources, the control actions and feedback to be able to fulfill those responsibilities. Otherwise, they're accountable but aren't able to fulfill what they're supposed to be accountable for. And so this is saying here, government industry accountability. So NASA, the government, and then industry. So it says to establish requirements. So NASA should flow down and tailor agency requirements, mission requirements, HRR, don't know what that is it human reliability requirements, don't know, standards, and then disposition requirements variances. And this star denotes items to be discussed further today in government assurance activities. By design, the CCP model allocates greater accountability to industry. So they've moved accountability from the government to the industry, which should be fine, so long as the control structure actually represents and reflects that. So the industry, flow down of CCP requirements and tailoring, elevate requirements achievability, evaluate requirements achievability. So these, in the context of established requirements, these are roles and responsibilities for those controllers. Manage development risk, development oversight, evaluate design and development risks from insight, produce management plans, reform risk reduction planning. So plans and plans. That doesn't sound like managing development risk to me, everybody. This bit is not managing development risk. Because it said over here that the industry partner is responsible for the design, development, test, and evaluation. So by definition, they should. They're the only controller in the structure, directly in control, that can influence and be responsible for risk management in the design, development, test, and evaluation. NASA is remote from that. So they can't be held responsible because they're too far apart. It must be the industry partner. But if the industry partner has been told by this slide here, oh, well, you just need to produce management plans, you need to perform risk reduction planning. Well, of course, the program managers and project managers are going to read that and think, well, it's organizational risk management, enterprise risk management, isn't it? It's not safety risk management. Because it says there, evaluate design and development risks. So that must be NASA's responsibility, surely. So they're passing the baby between them and not even realizing it. Establish certification baseline, independent verification validation, accept certification compliance, support joint test planning, accept residual risk. So they're accepting residual risk. When over here, the industry is said they're responsible for design, development and test and everything else. So this responsibility should really be over here. That's what that previous line said. I mean, yes, NASA should be involved in that decision, but they're not the ones that are accepting it. But again, this goes back to the conversation I had yesterday about the day before about the International Space Station. Who out of those two stakeholders is responsible for making sure that risk to the ISS is managed properly? Is that NASA? Is it a different part of NASA? It's not clear from here how that's dealt with. Perform system validation. Quantify residual risk. So this requirement here is forcing them to use fault trees and make up loads of bullshit numbers. You know, it's baked into the responsibility. So they're going to spend time and effort doing that at the sacrifice of doing actual safety engineering. Validate baseline certificate, quality assurance audits, accept problem resolutions, accept hardware, problem identification, resolution, corrective actions. What about software? What about software, everybody? What about software? Assess mission readiness, accept flight certification and residual risk. Well, surely it should be to reject it if it's too high, not just accept it. Maybe I'm being a bit too literal here, but I'm hoping you can see what I'm saying. Compliance evidence of hardware team readiness. What about software? What about resolution of unexplained anomalies? Why is that not mentioned here? You'll also notice that this is all about certification and not necessarily safety engineering. And quite often they can get mixed and matched, and you know we're not really sure what we're talking about here. It's this like convoluted interpretation of what safety is about. Oh well, it's certified, so it must be safe. And it's like, no, that's not the same thing. They're different. So yeah, so this allocation of responsibilities, whoever's done this, that's not adequate from a safety perspective. And if you were to use STPA, you could better define these roles and responsibilities. Yes, it'd be more detailed and appear more complex, but for complex projects and systems with high stakes such as this one, that is necessary. You know, let's use the tool. Let's use the power it provides us. And that's an allocation of responsibilities chart. So yeah, if there's a RACI chart, responsible, accountable, consulted, informed RACI chart, and you were to look at it through this lens, you could quite quickly identify weaknesses, as I've done on a few different projects in the past, with those responsibilities chart. And ultimately, if that stuff at the top is not nailed down, we shouldn't be surprised when we're having stuff like this happen. It's self-evident, you know. Anyway, overall, it is unclear whether shared accountability was not... Hang on. It's unclear whether shared accountability was just not understood by industry, partner, or just not fully embraced, or both. It is recommended that in future, NASA fully documents expectations of the shared accountability and clearly lays out NASA and partner roles and responsibilities. Yes, I agree with that. That's important. Totally get that. But the fundamental concept of shared accountability as it's presented is not adequate to maintain and manage safety. That's my humble opinion. And if you're involved in this stuff and you need help and support to sort this out, get in touch. Visit my website. Go to whiteley-safety.co.uk. Click the green button here. I need help now. Stick your name, email address, telephone number, and send me a message, and let's set up a call and have a conversation. Because STAMP, STPA, and CAS could absolutely fundamentally help with this definition at that high level. That's what it's designed to be able to do. Okay, NASA needs to have open and honest discussions about the risk they are accepting when they allow deviation from this contract and be willing to live with the consequences of that risk. Yes, I agree that that is the case, but as it's described so far, that is a high risk control structure that, in my opinion, is not adequate for the level of severity that is happening here, that's involved. Okay, so CCP shared accountability model. So traditional model, shared assurance model. So NASA development program, commercial services acquisition. So shared accountability is yellow, allocates greater accountability to industry by CCP design. So you've already remember what I've said about shared accountability. If it's shared, no one's accountable. It needs to be distinct. You are responsible and accountable for this. You are responsible and accountable for this. And it needs to cover both tasks and completion of tasks and actions, but also the engineering artifacts, requirements and test results and all of that good stuff. And also whether it's operations or design. I think you know where I'm coming from. Shared assurance minimizes overlap of responsibility by utilizing the most knowledgeable skills to support both oversight and insight activities. I don't like the sound of that either. I think that's wishy-washy. It sounds good, but in practice, the control structure needs to be super sharp to support that. Risk-based insight, yeah, I don't like the sound of that. It sounds great, but in practice, it's a load of nonsense, in my opinion. Allows risk-based decision-making process to derive insight, surveillance, and product assurance actions activity to ensure mission success. No, it doesn't. Risk-based insight does not ensure mission success. It ensures that you're going to miss stuff and you're not going to know about it until something really serious happens. And again, the balance between program risk, commercial risk, and safety risk, they're two different things. Yes, they're all risks, but they are managed in different ways, and that should be recognized and respected. So let's have a look. Mission success, NASA cert requirements. So hardware, software, contractors, program authority, technical authorities and supporting organizations, engineering, S&MA. Don't know what that is. What's S&MA? S&MA. Is it safety and mission assurance, presumably? Yeah, I think it probably is. So let's just... safety and mission assurance, S&MA, question mark. Health and medical flight operations, contractors, service providers, program authority, engineering, S&A, FOD. See, this doesn't make sense to me. Because fundamentally, the control structure should be the same regardless of who these are. The difference is who actually fulfills those different parts of the control structure. This just seems to shove responsibilities around without actually making it clear which ones are whose and how they're going to be coordinated. Because the contractors themselves should have some level of safety and mission assurance. They should have some level of engineering. So how do those contractor and NASA organizations interact with each other? And who referees that? Who referees and make sure they're behaving appropriately? I think this model is too simplistic. I highly recommend using STPA to build a control structure for this and then generate the roles and responsibilities and then allocate them to the organizations. Make sure that control structure influences how those organizations interact with each other and that it's documented, as it says up here. Where is it? NASA needs to document it, needs to have open and honest discussions about the risk. Where is it? Yeah, there we go. NASA fully documents. But again, this takes time. It's a lot of work. It's a project in its own right doing that before you even start doing the actual project. There we go. Are there any comments? Is anybody talking to me in the chat? Please comment in the chat. Let me know where you're watching from and if you've got any interesting experience you'd like to share. Let's just have a quick look while I have a drink. There we go, unmuted. Don't want to inadvertently mute myself like the other day. Okay, in addition, some flexibility needs to be built into the contract to account for NASA's need to drill down into a system once major risks are identified. In this case, Boeing failed to supply that access for themselves, so when issues arose, there were problems getting the data. Okay, so what's going on there, Boeing? What's going on? Is it just access to PDF files in a online repository, or is there something else going on there? Because in theory, if there are some major risks that are identified, the people that have identified them should be NASA. They should be Boeing, and they should have done lots of work on it already. And so when they talk to NASA, apparently it should be all a done deal, all sorted. NASA shouldn't really be needing to get involved in the detail of it from a technical perspective, but if they do, that should be welcomed and supported. And Boeing should be taking the lead on it, because it literally says, I'm pressing on the wrong screen, it literally says the industry partner to be responsible for the design, development, test, and evaluation. So they should be doing it all. And then getting NASA involved and building relationships with them. So if that's not what the industry partner's doing, and I think that's what this says here, shared accountability was just not understood by the industry partner or just not fully embraced by the industry partner, then yeah, okay. But if they're not doing that, then who is holding them accountable to make sure that they do that? You know, who's the referee in this situation? Yeah, all future partners should be required at a minimum to have access and or reach back to component level data until after the program goes into operational mode, or ideally for the life of the program. Right, I'm going to get on my high horse now, just for a minute. There should be the ability to go back and look at any of the data down to component level for the life of the program, and also beyond the life of the program. Especially if this system, this platform and parts of it are going to be reused for future missions. And also if there is an accident or incident investigation in the future, you need to be able to get access to that information and understand what was going on. I mean, my experience with the Nimrod MR2, Nimrod review that I was involved on the periphery of as part of a contract, one of the big challenges for that investigation was the access to available information about the modifications performed to the aircraft type throughout its life, because it was a very old relatively speaking, it was an old aircraft with lots of modifications over time. And in fact, each aircraft, each tail number was pretty much a custom built aircraft in its own right. You know, they were all built on production lines, but at the age of manufacture, when these things were manufactured, they were basically hand built. So each one was unique and different. And then on top of that, it's a military aircraft. And so each one is going to have various different modification standards applied to it. So as part of a safety program, a safety management system, if you have an incident with one of those aircraft or multiple aircraft, you need to be able to go back from a safety management system perspective and have a look at it and understand the context of what went on at the time. So this have access and reach back to component level data is absolutely a fundamental requirement. And again, Boeing should, the manufacturer, designer should already be doing this and storing that information. It shouldn't be subject to the typical corporate philosophy of you only need to keep the data for 10 years or 12 months or whatever it is. It should be program specific, system design specific, and kept for the life of the program and potentially beyond. Anyway, I'll get off that high horse. Right, let's keep going. So let's put that up there out of the way. There we go. Got too many jigsaw pieces, everybody. Right, so this one, wouldn't it be nice if the investigation said where this responsibilities chart is from? Is this part of the contract, or is it just one of those slide packs that gets thrown on the screen, during contract negotiations and never seen again? You know, how do these people in these organisations know what their responsibilities are? How is it communicated to them? What does the control structure look like? Okay, so this next slide is risk-based insight approach. This just conceptually, I just think this is nonsense, but that's just me. From a program risk perspective, you know, fill your boots. Not really too fussed about that. But from a safety risk management approach, we shouldn't mix the two, or it should be done very, very carefully by responsible adults. Under shared assurance, a risk-based insight approach is used to focus resources. CCP continually examines both provider-specific risk factor, what is a risk factor, and unique design features to determine the level of penetration required for risk assessment. Well, when you say risk assessment, what do we mean? Do we mean program risk assessment to make decisions about how deep we go, or are we talking about actual engineering safety risk? The following pictorial shows a notional example of how the NASA InSight activities change in accordance with a determined level of risk. So provider, this is a bit difficult to read, I'll just zoom in. So provider risk factors, S, E and I approach. Don't know. Staff experience, peer review, independent review, mature control standards and processes. Again, this is the first time they've done it, so mature and controlled standards and processes. I think that's a bit naive. Unique design factors, system contributions to risk, system maturity, complexity of design, associated hazard maturity, design maturity, uncertainty, demonstrated design reliability. Reliability, everybody, yeah, it's reliable, but it's dangerous. Complexity of design, I think that should be expanded to consider complexity of the control structure and how the organisations interact with each other. Because this topic over here about where is it? Boeing failed to supply that access for themselves, so when issues arose, there were problems with getting the data. This organisational, so I'll put org, and contractual complexity. It'd help if I used a pen, wouldn't it? Let's use a pen. Here we go. Contractual and organisational complexity. I suppose that's not a design factor, is it? Because that's about the actual product of the process. Yeah, I don't think this is good enough. I don't think it's detailed enough. I think it's not looking at the right things. You know, if this was let's take our little jigsaw puzzle. If this was the risk-based insight approach, which is the control algorithm and beliefs, these are the things that this controller needs to look at, this risk-based oversight insight approach. So this list of stuff is not going to detect and deal with the issues that we've spoken about that's in this investigation report. It might touch on the periphery of some of them, but it's just not good enough, I don't think. Okay, so provider CCTS maturity. Oh, what does CCTS mean, everybody? CCTS. Is it commercial crew transportation system? There it is, look, mate. Oh, look, management plan. Yeah, we'll have a look at that. There we go. Boeing's crew commercial transportation system maturity. I think it's a bit of a joke, to be honest. I know that sounds bad, but if they didn't get the design for OFT1 right for flight tests, collecting flight test data, and then they didn't do it for OFT2, and then they went flying with people on board for the third flight, that shows such immaturity from a safety management perspective and a program management perspective that, well, yeah, maybe I'm being a bit overly critical, but it's really not good. And this, as this seems to be described, doesn't seem to cater and detect any of those kind of issues and address it. So this is not a very good approach. It's not suitable. So one of the observations that should be added to the report is this method, this approach is inadequate and needs to be re-engineered. And we recommend using STAMP to do that, STPA to do that. Okay, so let's zoom in and have a look. So we've got providers, developers, and delivers ECLS design. So that's, what's ECLS? Oh, bloody acronyms. ECLSS. No, don't know what that is. No, don't know what that is. So develop and deliver design, complete CDR of design, provide component fail qualification testing, successfully complete majority of qualification testing. NASA Insight recognise high risk due to design behind schedule, comprehensive risk assessment required. NASA Insight recognise lower risk, audits to verify implementation in critical areas, and review of changes to design as required. NASA Insight recognise high risk, comprehensive risk assessment required. NASA Insight recognise lower risk, audits to verify implementation in critical areas. The depth of penetration of NASA Insight activities vary based upon the recognised level of risk derived from both provider, specific risk, and unique design factors. Been blunt, I don't think that's very good. I don't think that's adequate for dealing with this situation. In fact, I think this could have contributed to this situation. It's a bit of a distraction from actually dealing with safety engineering and program issues. But that's just me. You know, I'm talking about safety risk management, not program risk management. While in theory this model should work, no, I don't agree. In theory this model should work. I think this model is nonsense. But that's just me. Its execution had issues for this program. It is recommended that those issues be studied and lessons learned from its execution on CCP be thought through before applying this model to new programs. Yeah, so I'll just say it again. If you need a hand doing that, give me a shout and we can do that. We can sort that out and make the project not only safer, but less risky. Some of the examples of issues with execution of this model and shared accountability addressed in interviews include several standards or requirements were not flowed down from Boeing to its subcontractors. Oh, dearie me. So that is a control action not provided. So again, it's not really fair on the subcontractors, is it, if Boeing are not flowing it down or flowing it down late? Should the subcontractors have to suffer for that? And of course, it then leads, this kind of behaviour then leads to degradation in trust amongst the stakeholders, such that the subcontractors will do literally what's in the contract. You know, they'll work to rule instead of being flexible and respectful and supportive. You know, and that's a toxic way to manage a safety critical project. And you know, it's not a fault of the individuals involved. You know, they are doing the best that they can. And if this is what's going on, you know, they're taking on risk as well. So this, yeah, exactly. What the investigation needs to understand why this didn't happen. ATP hot fire requirements. Boeing failed to ensure adequate insight for their own team into not only Aerojet Rocketdyne's design, but also to the suppliers below, including the thruster provider Moog. Okay, so why were they not talking to each other properly? Why were they not talking to each other properly? That's ridiculous. The investigation should find that out. Boeing failed to attend component level PDRs and CDRs in the propulsion area. Well, why? Why did they do that? Was it because they weren't resourced? Is it just people issues? People run well? Whatever it is, COVID, all that other good stuff. Again, the program should be designed to be able to deal with that and address that. It shouldn't just be, oh, it failed to do it. When issues arose with propulsion components, Boeing did not have adequate documentation on the components to fully understand the issues. Okay, great. So why? Why was that? Surveillance plans were supposed to be based on Phase 2 hazard reports, which were provided in the 2018-19 timeframe. However, designs were set well before that date, and system builds were occurring already in the 2015-16 timeframe. So they were building the things 4 years before. Again, where does it say in here about making sure that parts of the program are coordinated, and that if you're building stuff before you've finished, the hazard analysis and set requirements and everything else, that should be flagged as a significant program risk and dealt with accordingly? Yeah, I mean, I've been involved, dealt with similar. It's not a surprise, it's just very disappointing. Boeing failed to adequately implement the validation part of V&V. Yeah. This is pretty damning. Why? Why would it make sense for Boeing not to do that? Integrated, because there's loads of great people in these organisations, fantastic people, the best in the world at what they do. So what is it about the structure around them that set them up to not be able to do this? What is going on? Integrated doghouse testing was not performed. Integrated software testing was limited. I mean, that, for me, that is a bit of a warning shot, because that is a big contributor to the control loops and the potential for unsafe control actions. Human in the loop testing was limited. Again, that, when they were switching between manual and automated control, that could be a significant issue. NASA approved oversight documents, even though insight data was required to fill in gaps from the document. Yeah, so why would it make sense for them to approve documents when other stuff was required to fill that in? Why would it make sense? Okay, so that was a lot there, and my throat is really sore. Right, so let's just... so there's a recommendation there, look. And then there's another section there. So what we'll do is we'll finish this section, and then we'll call it an evening and pick this up tomorrow. So recommendation, CPMO, OCE shared accountability. Develop and implement new guidance standards for shared accountability on new development programs. I think it needs to go further than that. I think we need to be really careful with this concept of shared accountability, because fundamentally it's nonsense. A stakeholder, a controller in a control structure should be responsible and accountable and enabled by the control structure to do what they need to do. And those controllers need to coordinate with other controllers to deal with other program areas. I totally get that. But labeling it shared accountability sets up the wrong mindset in the people involved, because they'll be thinking, oh, well, if I don't deal with it, they'll be dealing with it. And things are going to get dropped and missed, and that's what it sounds like here. There's loads of things that have been dropped and missed. I mean, the bit there about Boeing did not have documentation, that is interactions between two stakeholders. So if they didn't have adequate documentation, why was that? Why was that not addressed and sorted out? What is the issue there? What are the issues there? Is it because it was contractually not required? And the suppliers were like, well, we're not giving you this documentation because it's not in the contract and you've not paid for it. And then you end up with project managers arguing about timescales and accountability, responsibility, contracts and funding. And they are actually hampering the safe conduct of the program. But they don't see it like that because they don't have that perspective. Observation 4, lack of understanding certification of flight readiness. Okay, so again, why? Where's there we go, that's one. Certification of flight readiness. That's something I might need to talk about. Okay, so NASA's overall understanding of the functional distinctions in certifying a new commercial vehicle compared to traditional NASA programs appears limited. This is evident by the surprise and/or emotional response to available information on a system once a failure has been realized. This is interesting. I'd like to know more about this. When we say emotional response, who are we talking about? Are we talking about project managers or safety engineers? Who are we talking about there? Comparison of engineering certification of flight readiness on traditional program versus engineering COFR on commercial crew. When looking at engineering certification of flight readiness for traditional cost-plus contracts for human spaceflight programs, Shuttle, Orion, and comparing it to the engineering for COFR for commercial contract implemented for the CTP. The biggest difference is the certification only covers only safety of flight, whereas the traditional program covers safety of flight and mission success. Well, there's your problem. There's your problem. So the commercial company is not responsible for mission success. That's what that sounds like to me. They're responsible for safety, but if you've got a mindset of, well, everything's a problem, focus on failures. Failures are the problem. And by the way, failures are so low probability we don't have to worry about it. Of course, this is going to happen. But interestingly, STPA stamp can deal with both hazards to safety and hazards to mission success. So you could nail this 2 birds with 1 stone using STPA. Safety of flight focuses on preventing accidents and injuries to both astronauts and personnel on the ground. It should also be about planetary protection as well. So I'm going to get on my high horse about planetary protection, because you don't know what the spacecraft's going to be carrying in the future. So should we consider planetary protection as well, everybody? I think that might be a good idea. I'm sure all the planetary protection officers watching this will be like, yeah, Simon, yes. I can't even spell planetary. Planetary protection. Yeah, my handwriting is not very good today. There we go. That'll do. Right. Mission success focuses on achieving the predefined objectives and desired outcomes of the mission. A flight can be safe and not meet all mission objectives, but generally success can't be declared unless the flight is safe. This means safety of flight is a subset of mission success. Surely mission success is anyway. In addition, some of major differences between the different approaches deal with the depth of penetration into the design. This includes access and insight into sub-vendors' data below the subsystem level, failure modes and effects analysis, and CIL data requirements. CIL, what does CIL mean, Simon? Come on, let's try and figure that out. I can't remember. Is it critical items list? Something like that. The level of VCN. Oh, come on. I know what VCN is. Come on. We had this vehicle certification, verification closure notice. There we go. And cert package data audit use solely for insight and risk-based review only in many areas. In each case, the traditional programs had more stringent requirements in these areas and better access to all design and verification data at all levels. So what it's kind of saying, I'm interpreting, that in traditional programs, NASA would have more detailed insight into the technical design and requirements of whatever it is involved with suppliers and subcontractors and all that stuff. But they don't have it on this one. So who does that more detailed review? Someone has to do it. If the supplier, Boeing, is not doing that, then of course we can't be surprised when things are missed, requirements are missed. So someone needs to do that, and the supplier should be doing it. But if they're not doing it, then, you know, what we're supposed to do about it, it needs to be enforced. These differences are what NASA brought into with the commercial contract. So I would love to do an STPA review of this commercial contract. I'm sure we can find some huge gaps in it and make it even better. The crew flight test propulsion system failures on the crew commercial program perhaps demonstrate the need for a compromise approach to the commercial contract. We are not advocating for returning to the full SSP or lesser approach, Orion approach, but perhaps finding a middle ground where deeper penetration is required in the commercial contract via contract, requirement for access to sub-vendor data, more Type 1 deliverables in these areas, Earlier access to the design. Yes, if you had STPA, you could do that. In areas that are traditionally more risky, i.e. propulsion, pressure vessels, welding and fracture control issues are common. Parachute systems, systems containing valves, and that the commercial program set aside adequate funds for risk buy down in these areas. Okay, fantastic. Right, let's have a look at this. So this is figure... I agree, but I think there's more fundamental structural issues that need to be addressed than that. And I recommend building a control structure and figuring that out and engineering the control structure to make sure responsibilities and accountabilities are properly allocated and resourced, and that the right people with the right technical expertise get to see the right level of information at the right level of abstraction. Right, so the engineering COFR comparison study 2012 timeline. So somebody's done this work in 2017 and it's a draft version. So whoever that was, well done. Good work. So let's zoom in then. So we have endorsement area, most involved, not involved. So 0 to 1 going that way. There we go. Right, so we've got conduct, perform. So this is like a Raki chart. Conduct, perform, approve, concurrence, audit, surveillance, no task. And then there's the SSP, the MPCV, the CCP. So I'm presuming that CCP is the crew commercial program and the other two programs are different vehicles, different programs. So system safety analysis. So this is for certification of flight. So is nobody responsible for doing it? That seems a bit weird, I would have thought. Again, approval, review and approval. They should be involved in that, I assume. It's interesting that reliability analysis is on a separate statement. That's a good sign. Probabilistic risk assessment. There we go. Interface control documents. Yeah, they're important. Hardware, software acceptance. Vehicle processing, test and inspection, launch commit criteria, that's very important. Flight rules, integrated vehicle readiness, crew procedures, problem reporting and corrective action, waivers, deviations and exceptions, limited life items, material review boards, alerts, mission support, independent assessment. And then I can't read all of that, it's too small. Requirements, compliance, certification, risk management, hazard report analyses, acceptance plans, anomaly resolution, FMEA, mission flight something requirements, mission operations, flight rules, production insight, flight software loads, open paper, CHIITs, dunno, facility certification, vehicle processing changes, limited life items, packaging, handling and transportation, payload, cargo integration and checkout, alerts, manufacture assessment, manifest assessment, trending analysis, mass properties. I thought C of G should be in there as well. Anyway. Yeah, I'm not sure I understand this. Similar... Yeah, I don't really understand this. Yeah, I don't know. It's too small to read. I think what it's trying to do, and I think it's a good idea, it's trying to understand the difference between the traditional approach to certification of flight and the commercial certification approach to flight. And essentially this is a list of activities, tasks and responsibilities that should be allocated around the control structure. And depending on the engineering, the traditional flight certification of flight readiness, that list of tasks should be exactly the same for the commercial program, but the way those responsibilities are allocated to the control structure is different. But of course, the control structure between a traditional previous program and this new program is already different. So how do you make sure that those responsibilities, tasks and accountabilities X, Y, Z is actually allocated properly? Again, that's something that STPA can help with. It will be a bit of work to do that, but that will make your control structure so much better. And of course, the people involved in that will better know what their roles and responsibilities are and be better able to execute them. Okay, so that's a few pages. We're now on page 112. Fantastic. So we've made some really great progress, should I say? We've got a couple more pages to go, and then we're into culture and decision making. My throat is a bit rough, a bit sore, so I'm not going to finish these last 2 pages today. I'm going to savour those for tomorrow, for Friday, and we'll make a good go. So yeah, just to summarise again, if you are interested in taking part in a live workshop, visit my website whiteley-safety.co.uk. Click on this button here. Join the waitlist for the live workshop. So the intention is, once I've got through the report, the whole end-to-end of it, I will put together some slides, essentially a case study set of slides, and I will present them at this workshop. And we can get together live on Zoom, and we can talk about these issues, the challenges. You can bring some experience of your own along, and we can really talk about STAMP, STPA and CAST in this context. So please join the waitlist, and then when I finish the review and set the date, I'll send you an email with a join link on it, and we can get together on a live session. So yeah, fantastic. Well, I hope that was interesting. The plot thickens is all I can say. When we started out with this, I didn't really know what to expect. We've seen some very interesting things, very technical issues, organizational issues, control structure issues, and changes in roles and responsibilities over time. It's a very interesting case study, this. There's so much, so rich, we could learn so much from it. But again, it's whether the organizations involved are able to take that learning on board. And I'm concerned that, this report is great, but there are so many avenues that they could dig into. There's so much more value they could get out of this if they were to use and deploy STPA and CAST. So, of course, I'd be happy to help and support with that. But the purpose of this case study is just to get people's creative juices flowing, show them what the art of the possible is, so they can hopefully give it a go and see where they end up with it. But anyway, well, thank you very much for watching, and I will see you on the next live stream, which is the same time tomorrow, 1700 BST, UTC +1. Bring some refreshments, bring your friends, and make sure you bring some good questions. Have a good night. Take care.